So how many people have I ruined your day? Oh, 39, integral of the cosecant. So this one is a lot like integral of the secant in that somebody had to show us. We would have never thought of this on our own. I believe, if I remember right, that we're going to multiply this by cosecant x minus cotan x. I think that will work. And again, it's just memory. I certainly would not have been bright enough to figure this junk out on my own. Pardon me? Well, either remember the technique or memorize the formula. You got one of those two choices.
Right.
So if I let u be the denominator, then du will derivative of cosecant minus, excuse me, there's a minus generated there, right?
Mm-hmm.
Minus cosecant x cotan x. Derivative of cotan minus cosecant squared, so plus cosecant squared. Did that work? Oh, it did. Dx. So this is now the integral of dx over, or excuse me, du over u, which is ln absolute value u plus an arbitrary constant, which is ln the absolute value of cosecant x minus cotan x plus c. Yeah.
Would this be something that would be provided?
No, I won't provide this. You'll either memorize it or remember the technique on how to get it.
This is only for cosecants, right?
Well, secants and cosecants are essentially the same thing.
Yeah.
So when you're stuck, like, add 0 or multiply by 1?
I don't know how to tell you to think of that. I would never have thought of that. Somebody smarter than me thought of it, and then I remembered what they did. Story of my life. 45. Square root 1 plus cosine 2x. And this one has limits of integration, I believe. What are they? 0 to pi over 6. Okay. Man. Would somebody remind me what that formula was for cosine squared theta? That power reduction formula?
1 over 1 plus 2
cosine
I think it was 1 plus cosine 2 theta over 2.
Yeah.
So let's rewrite this as the integral 0 to pi over 6 square root 2 cosine squared x dx. We don't have to worry about absolute values here because the cosine is positive on 0 to pi over 6. So this is rad 2 integrals 0 to pi over 6 cosine x dx, which is rad 2 sine x, all evaluated 0 to pi over 6, which is rad 2 times sine of pi over 6 is 1/2 minus 0, so rad 2 over 2. Questions?
It's kind of one of those memory things too. Like I would never thought about like actually using that formula to.
Yeah, as soon as you see that 2x in there, you're supposed to be suspicious of double angle formulas.
Okay.
And double angle formula is power reduction.
Right. Okay.
So there's two formulas in one. 47 is 1 minus, is that 10 squared? Over secant squared? Well, 1 minus 10 squared is secant squared, isn't it?
Yeah.
No.
One plus.
1 plus 10 squared is secant squared. You want to change everything to sines and cosines? That's often a real good way to go. Or we might think about doing this. Now, I don't know if this will work, but see, anytime I see a monomial denominator, I'm going to at least give this a thought. That will work real well on this one, won't it? That's cosine squared. That may not work at all on this second one, though. That's sines over cosines. This is 1 over cosines. Did that work out?
Yeah.
And what's cosine squared minus sine squared? Oh, that's cosine squared plus sine squared. That's one of those double angle formulas. So we might have seen that more easily had we followed your suggestion. Her suggestion was to change everything to sines and cosines immediately. So had we followed her suggestion, we would have had 1 minus sine squared x over cosine squared x, all divided by 1 over cosine squared x. Notice that really sort of yells at you to use an old algebraic technique of multiplying top and bottom by the LCD. So if I do that, I get the integral of cosine squared x minus sine squared x. And notice we got to where we did get to, but a little more easily. So she had an excellent idea. And hopefully you're going to remember this formula, because otherwise if you use power reducing on that, you're going to suffer a lot. It's much easier now. This is 1/2 sine 2x plus an arbitrary constant.